Hi, this is Mrs. Houghton. Today we're going to be discussing one of our topics in consumer math. In Unit 3, the topic will be leisure, travel, and retirement. And actually, the specific topic is going to be about transportation and travel. One of the topics talks about the Pythagorean theorem. I'm sure you've seen this in previous math classes, and maybe it's been a while, but Pythagoras is the one who originated the formula that you see on the board right now. It's a squared plus b squared equals c squared, and it pertains to right triangles. What you may not realize is how it's used in everyday life. Here you see a cabinet maker making a cabinet, and one of the ways that they can validate that it is the correct dimensions, meaning that it has to be a right angle, is by measuring the lengths of the diagonals. This way they know that each corner is a 90-degree angle and will sit level. I mean, if you think about it, how many times have you gone past old homes, probably more in the city, where you'll see that the ground has settled and it's a little cockeyed, like the door frames or the windows. When that happens, you will not have the 90-degree angle anymore. Okay, it's really important in construction. Think about your kitchens, all the cabinetry in there, or maybe in your kitchens, even in your closets. I know there's a lot of times they've been doing a lot of cabinetry in closets, and you need them to be level and level with the floor, level with the walls, or else everything's just going to be really cockeyed. Another place where you probably don't really notice where we need to know the Pythagorean theorem is when we're talking about stairs. You may have the height of the first floor to the second floor, or you may not know how far out you want the staircase to go, but that will depend on the angle that you'll see at the top of the steps or at the bottom where it meets the floor. We want to figure out how many steps are going to be required to go from the first floor to second floor, from the ground level floor to the next level up. Again, this is something where you would use Pythagorean theorem to help you figure some of this stuff out. Again, you probably have done this in your geometry class, where we've used Pythagorean theorem. Sometimes what they'll do is they'll give you a problem where they'll give you the sides or the legs of your triangle. The longest side here, which is going from D to F, and you'll see it's also labeled with a lowercase c, that is your hypotenuse. The other two sides are your legs. The one that's from D to E, which has a measurement of 3, or from E to F, which has a measurement of 4. When we're using our Pythagorean theorem, it doesn't matter which one we call a leg, the DE or the EF. Okay, so when we put them into our formula, your a squared plus b squared equals c squared, it is your leg that is squared plus another leg that's squared that equals the hypotenuse squared. So again, the longest side is going to be your hypotenuse, that's going to be your c, and you're going to square the measurement of each leg. And again, think now of your operations. When we're adding, it doesn't matter if I say it's a squared plus b squared, or if I say b squared plus a squared. I'm squaring both measurements and then adding them together. So it really doesn't matter which leg I call A or which leg I call B. So in this case, we said A was going to be 3 and B was going to be 4. So when I put that into the formula, 3 squared plus 4 squared equals c squared. C is my unknown. My hypotenuse is my unknown. So now we're going to put this into the formula to solve for it. So 3 squared is 9, 4 squared is 16. When I add them together, I'll have 25 equals c squared. A lot of times students will stop at this point because they think like, oh, I found c, I'm done. But you have to remember that is c squared. We must take the square root of both sides, the square root of c squared and the square root of 25. Square root of 25 will give you the 5. The square root of c squared will just give you your variable c. Again, I'm pretty sure you've had this before, but sometimes it's just good to hear it again. Sometimes you're going to be given a triangle where you're given the hypotenuse and you're given a leg. You have to find the other leg. Again, you're still using the same formula. You're still plugging in your variables into your formula, but we might have to do something a little bit different because you're not, your variable may be added to a number. I know that sounds confusing, but let's look at the example on the screen. We have a squared plus b squared equals c squared. We have a leg, which is 5. We have the hypotenuse, which is 10. Okay, again, they've given us the drawing, so we know that this is the hypotenuse. If they didn't give us the picture, we may not know if 10 was a hypotenuse. It is the largest number of the numbers they gave us, but with this picture, we know that it's the hypotenuse. So I'm going to plug in the 10 for my c, and you'll see I have 10 squared there, and I just decided to pick 5 as my leg for b. So I'm solving for a. So a squared plus 5 squared equal 10 squared. And then again, using your calculator, square both the 5 and the 10, and you'll get your next line in the equation. A squared plus 25 equals 100. And then I need to solve for my variable. My variable is a squared, but you'll see that I have 25 on the same side of the equal sign as my variable. So what I need to do is I need to eliminate that because I need to isolate my variable. I need to get my variable by itself. So what I do is I subtract 25 from both sides of my equation. Now I know I need to subtract because if you look at your equation there, it says plus 25. So in order to get rid of it, I need to do the opposite. So the opposite of a plus 25 would be a negative 25, which really means I'm subtracting. Minus 25 from both sides of my equation. We'll cancel out the 25 on the left side of my equation, and then I have to reduce the 100 by 25. Now, sometimes people will have to use their calculator, but if you think in terms of money, if you had $1 and you're getting rid of, you lost a quarter, you're left with 75 cents. Same type of concept. All right. So now, as I reduce this, I have a squared equals 75. Now remember, that is not my final answer. That's what a squared equals. I need to find what a equals. So I need to take the square root of both sides. So when I take the square root of 75, I'm left with a crazy looking number. You see it says a equals the square root. That's that thing that looks like a division sign with a little check mark in the beginning. That is called a square root symbol, okay, or a radical sign. So I'll have a equal the square root of 75. But in Odysseyware, they're not satisfied with you just leaving it like that because you can simplify that even further. To do that, think about some numbers that would that you multiply together to get 75. Now I had given you an example of quarters, right? So we have 3 quarters would equal 75 cents. So I could simplify inside my radical sign to say the square root of 3 times 3 times 25. Because if I have 3 quarters, that's going to give me 75 cents. And since it's 3 times, or it's the square root of 3 times 25, and I know that the square root of 25 is 5, I can pull that outside my radical sign. So you'll end up with 5 times the square root of 3. We're not looking for you to put it into your calculator and get a decimal. You're going to leave it with the radical sign in this in Odysseyware. They do not want you to just put it into your calculator. They want you to kind of think through the process. Here we have another example where they've given us all 3 sides of the triangle. Now, why would I use Pythagorean theorem for this? Okay, remember we had talked about the cabinet maker. Okay, the carpenter was measuring the angle, which is the hypotenuse. Okay, or I should say that from corner to corner. So I should say he's measuring from corner to corner, which is your hypotenuse. So he physically has the length of it. Okay, he also has the length of the base. He has the length of the height. So he has all his measurements, but he needs to know if it's a right angle. So what we're going to do is we're going to take all these measurements and we're going to put them into our Pythagorean theorem. If we expand them and then add the 2 legs together, if the left side equals the right side, that means it is a 90-degree angle and it is a right triangle. In this example, we have 6 squared plus 8 squared equal 10 squared. 6 squared is 36, 8 squared is 64. When I add the two of them together, it gives me the 100. The left side of my equation is equal to the right side of my equation. So yes, in this example, it is a right triangle. The carpenter could continue working because he would know that this is in fact a right angle. He can continue. Now, if you look at this triangle here, you'll see that each of the sides are just one more. In our first triangle, we had the 6, now we have a 7. Our hypotenuse was a 10, now this is an 11. Our leg or our base was an 8, now this one's a 9. So you think like, oh, okay, it's just one off. They're all increased by the same number. Okay, so you would think that like my ratio, it's the same, it's all good, right? But now if I put it into my formula, 7 squared plus 9 squared equal 11 squared, you can see that when I add them together, my left side equals 130, where my right side is only 121. So even though we can't see the difference, it's really hard to see with the naked eye, I would know that this is not a right triangle, and I'd have to readjust in order to make it a right triangle. Okay, we're going to go for a different real world question here. You have a UPS truck who was at the, actually there's two of them, who are at the Phoenix airport. I'm thinking locally, aren't I? Phoenixville. And they're going to be traveling along roads, okay? As they leave, they're 90 degrees apart. And the first truck actually leaves 30 minutes before the second truck. I guess they're loading it, so it's taking them some extra time. Okay, and then the first truck is traveling at about 42 miles an hour, and then the second truck averages about 50 miles an hour. Okay, and they want to know how far apart will they be after the first truck has traveled already 3.5 hours. Okay, so remember they're going in not opposite directions, but they're going at, one's going up and one's going to the right type of thing. But it gets confusing when you're trying to see all that. So let's draw a picture. Okay, so there's my airplane. You can see the truck 1 is going up towards the top of my screen. The truck 2 is going down towards the bottom of the screen. Okay, and as we're looking at that, let's put some numbers to it. Okay, we know that the one truck is traveling 42 miles an hour, and he's traveling 3.5 hours. We know that the other truck is traveling faster. He's going 50 miles an hour. Now, this is where it gets a little tricky with some of our questions, because they're telling us that the first truck traveled 3.5 hours, okay? And that's what they want to see. After 3.5 hours, how far has he gone? But if you look at the problem there, it said truck 1 left 30 minutes earlier. So when I'm looking at truck 2, which is my green part, you can see that only has my time of 3 hours, where truck 1 has 3.5, okay? Our formula for our distance is a rate times time. The R stands for the rate, which is the 42 miles an hour, and the T is our time. So for the blue truck, the truck 1, they've already has traveled 3 hours and 3.5 hours. I was going to say 15 minutes, but that's not right. 3 hours and 3.5 hours. Okay, so now we can calculate that. We can see that truck 1 has gone 147 miles. Truck 2 has gone 150 miles. But this question is not asking how far they've traveled. They're asking how far apart are they. So I'm looking to see how far it is from the blue star to the green star. Okay, why would we care about this? Well, here's an example that, maybe truck 1 broke down and truck 2 has to, run up there and go get their packages. They've delivered all their stuff. How long is it going to take him to get up there? And in order for us to know how far that is, we have to know what the distance is. How long would it take him to get up there to help truck 1? Okay, this is something that would be referred to as logistics. You'll see a lot of that in your, especially Christmas time. We have, UPS, you got the Postal Service, you have Federal Express, and I don't even know all the other ones, all the other carriers that are out there. But this is a problem that they would be interested in because, they have to be able to make sure they make their deliveries on time. Okay. So in this particular case, we knew that at the beginning, they told us that they were driving 90 degrees apart. So we know that it's a right angle. we're looking for the hypotenuse in this particular problem, we can use the Pythagorean theorem. Okay, so now we know a squared plus b squared equals c squared. Well, remember, we already know the legs. We did the distance from where the airport was to the blue star, from the airport to the green star. We've already got the length of our legs. So we're just going to put it into our formula for a squared plus b squared equals c squared. So as we go through the calculations that you see on the screen there, we can see that the two vans, the two trucks, are 210 miles apart. So, in this particular case, they may say, okay, we can have this man go up there and help truck number one. It's going to take him this long to get there. And, that they can rework their schedule if need be. Okay. These are the things that you could use Pythagorean theorem for when it relates to something that's traveling, not so much the carpentry that we talked about before. Here we go. Another one, another distance type problem, right? Two planes, yeah, I'm sure you always remember those, the trains, you're leaving the train station at, so here we are. Now we're doing a plane. Okay. So these jets here, they're flying, one's at 415 miles an hour. The other one's at 375 miles an hour. Okay. They're both leaving New York at the same time. One flies north, one flies south. And they want to know after 4 hours, how far are they apart? When I draw this picture, okay, you have to think about north, south, east, west. What's our direction? You can see that the plane A is my red line, and the plane B is the blue line. They're going in opposite directions. Because they are going in opposite directions, it's a straight line. It's not 90 degrees. Therefore, I cannot use the Pythagorean theorem. This one is strictly just a distance problem, okay? So we're going to say, okay, the plane one is traveling at 415 miles an hour for 4 hours. Okay, so they traveled 1,660 miles. Same formula for plane two, and they're going to be flying 1,500 miles. So how far are they apart after 4 hours? We're just going to add those two numbers together because they are truly traveling in opposite directions. Okay, so the Pythagorean theorem does not apply in this particular case. So let's talk about that one step further. Let's talk about a distance formula. Now that one was pretty simple. We were going north, one was going south. It was a 180-degree straight line if you think about what the angle is, okay? But what if it's not as simple as that? Now I have, in this one, we have somebody who's traveling across the country. They're moving. They're going from San Diego and they're heading out towards the Great Lakes. Okay, it's a straight line, but it doesn't fit nicely on our grid. So we have a different formula when we're talking about the distance. Okay, it's you want to say, oh, I'm going to use the same thing. I'm going to use Pythagorean theorem. Well, we don't really have to. Okay, what we're going to be using is something called the distance formula, and the distance formula is the square root of the differences of your x values plus the differences of your y values. Now that sounds really like crazy, I'm sure. But really what we're doing is we're trying to find how far it is on our grid. We're kind of looking for the legs in order to find what the distance is, like we did for the Pythagorean theorem. So the differences in my x's would be just if I was traveling along just, a straight line only on my x-axis. I'm going from from 1 on the grid to 5 on the grid. Okay, I'm looking at the distance of my y's. I'm going from 2 on my grid up to 5 on my grid. So I'm going to use the combination of both of these, and then I'm going to add them together in order to find the distance. So let's look at our example. Now you'll notice that point 1 has the ordinates of 1, 2. So my x value is a 1 and my y is a comma is the 2. And if you have trouble remembering my ordered pair, my x and my y's, always remember that it goes in alphabetical order. X comes before y. So my ordered pairs are x, comma, y. Now, I know a lot of times students get really nervous like, well, how do I know that's point 1? How do I know this is point 2? Don't worry about that because I'm going to give you an example. Or I'm going to show you with this example where it doesn't matter which one I call point 1 and which one I call point 2. Or if I get my formula backwards. Here I'm saying x1 minus x2. What if I had said x2 minus x1? I got it backwards. Doesn't matter. As long as we're consistent with what we're doing, we will be fine. Okay? So in this particular case, I see that my point for x1 is the number 1, which is my purple value. My x value in point 2 is 5, which is my pink value. You can see how I'm plugging them into my formula. Again, I'm doing the same thing for my y value. 2 minus 5. 2 is the y sub 1, and 5 is y sub 2, my purple and my pink. And then I'm just going to do my arithmetic. Please use your calculator if you get nervous when we're talking about negative numbers. Because if you look what's inside my parentheses, you can see my second number is larger than my first. So you're going to end up with a negative number. Have no fear though, okay? Because we know that with a distance, you'll never ever have a negative number, okay? Distance is not negative. Distance is always a positive number. In this particular case, when I subtract those two numbers inside my parentheses, I'm getting a negative number. So how can I not have a negative answer? And the reason is because we're squaring the numbers, okay? A negative 4 times a negative 4 will give you a positive 16. A negative 3 times a negative 3 will give you a positive 9. So by squaring our numbers, whether they're positive or negative, you're always going to end up with a positive number. Therefore, your distance will always be a positive number. Finishing up this problem, we see that 4 squared is 16. I'm sorry, negative 4 squared is 16. Negative 3 squared is 9. I add the two together, and then I'll get the square root of 25. And then I see that I have to take the square root, which means that my distance between there would be 5. Now, it's kind of funny when you start looking at where it is on your grid, you think like, wow, that's really odd. How that has a length of 5? Because you're only seeing that, like, my x value has a difference of 4, my y value has a difference of 3. But remember, you're doing it in a two-dimensional environment. You're not just working off one number line. Now, I had said to you, don't worry if you don't remember which point is point 1 and which one is point 2, or maybe you had the formula backwards, x sub 2 minus x sub 1. In this particular example, I said, let's switch them out. X sub 1 and y sub 1 is the top number, my 5, 5, that ordered pair. And x sub 2, y sub 2 is the one that's lower on the graph. Okay, so that's the opposite of what we did before. When I look at this, that means I'm going to be putting my numbers in, or I'm putting my pink numbers in before I'm putting in my purple numbers. And as you can tell, I like to use colors so that when I'm getting tongue-tied, at least if I give you the colors, you can see the consistency of what we're talking about. All right, so like I did before, I'm going to subtract the numbers that are inside my parentheses before I use my square. So now I end up doing 4 squared plus 3 squared. And if you recall what we did before, we had a negative 4 and a negative 3. Both of those numbers were squared. I'm ending up with the exact same information because I squared my numbers. 4 times 4 is 16. 3 times 3 is 9. I still get the positive numbers for my distance. So I hope this eases your mind in terms of like, I'm never going to remember which point goes first or what exactly is the formula, because you're really looking the distance from the different points, but you have to do your x's together, you have to do your y's together in order to make them work in a two-dimensional environment. If you have any questions regarding this lesson, or if you just are getting confused, you think you have it, you just want to verify something, please come see me or send me an email. There are 3 ways right here that you can contact me. You can contact me email, and then really there's 2 ways in email. You can send it to me right here at kathleenh@cciu.org, or you can do it through Odysseyware using that help button. When you use the help button, it automatically sends me a message in my Odysseyware system, and it actually tells me which problem that you're struggling with. You can come into the virtual office. I'd be more than happy to work with you. And then you can also call me. That's my direct line. You can call my desk, and if we can, talk it out over the phone, great. If not, we can try and get you into the virtual office if you're struggling. If you just want to talk to me and kind of get an understanding of how you're doing with something, please call. I am available to you any way that we have listed here. Hopefully, this lesson was something that helped you with understanding about Pythagorean theorem and also your distance formula. And you also see some real world applications as to why we have to understand how to use those formulas and why we need those formulas. Okay, well, you have a great day, and I hope to see you in the virtual office or call me. Thanks. Bye.